Hi all, and welcome to the Emergent Vision Technologies high-speed imaging presentation. I am John Allett, President, CTO, and company founder, and I would like to present our perspective on high-speed imaging. Some highlights about Emergent are presented here. We are a multi-award-winning company with a focus on high-speed GigE Vision product. We have many years shipping product ranging in speeds from 10 GigE up to 100 GigE. We have a strong focus on providing end-to-end technologies and support for customers' applications. We can fulfill most application needs. Lastly, products presented are available now. Here is a quick snapshot of the adoption of GigE Vision products ranging in speeds from 10 GigE up to 100 GigE. Emergent has shown how top performance can be achieved and opened up many markets, including machine vision, to the use of such technologies. Some companies are just now leveraging our efforts towards releasing 25 gig and higher speed product, but still a ways to go to release ratified and performance product. The focus of this presentation is going to be on the technologies involved in high-speed applications. These include interfaces, processing technologies, software, and the cameras. GigE Vision, or Ethernet, and Coax Express, or CXP, are seen as the primary interfaces for high-speed vision. We start with GigE Vision. Optimized GigE Vision uses header splitting in hardware available in off-the-shelf performance NICs and other processing devices. This is the same method used in SMPTE 2110 in the massive media and entertainment markets, which has also a zero tolerance for data loss. In this market, they rely on well-designed receivers, and as such, the off-the-shelf NICs provide header splitting technologies which are used in streaming implementations like SMPTE 2110, but also in message and connected protocols like RDMA and RoCE. We work with the same vendors who support RDMA and RoCE to use header splitting to achieve the most feature-rich and highest performance receiver, while adhering to the current and highly mature GigE Vision specification. CXP has started moving to an Ethernet-based fiber interface. Why is that? The CXP standard and coax cable was never suitable for high speeds. The CXP standard and coax cable was never suitable for long cable lengths. How has GigE technology adapted to accomplish the highest speeds? The only changes are firmware and software to the off-the-shelf NICs. How has CXP technology adapted to accomplish the high speeds? A completely new interface, protocol, hardware, firmware, and standard managed by a small group of proponents within the machine vision industry. A completely new frame grabber, firmware, software to support fiber-based CXP. So when will I see CXP over fiber product? A very small handful of companies are involved in the specification, and products are coming slowly both on the camera and the frame grabber side. Initial products are 40 gig QSFP+, which is the simplest of implementations since it simply creates 4 times 10 gig lanes. The major switch vendors consider 25 gig as the new 10 gig, 50 gig as the new 40 gig, and then there is 100 gig. 40 gig is already being considered outdated technology, with 25 gig, 50 gig, and 100 gig providing the best density and price performance ratios. Even slower will be the adoption of 50 gig, 100 gig, and beyond, which is already available now in Emergent Ethernet-based cameras with complete accessory portfolio. Emergent 25 gig cameras have already been available for 5 years, and 10 gig cameras for over 10 years. Emergent 100 gig cameras have been shipping into the highest performance systems for 3 years now. So here is what a 12 times 25 gig camera system would look like with Ethernet versus CXP12. The Ethernet solution has 12 25 GigE cameras, a switch for PTP synchronization and multiplexing, the 12 cameras onto dual 100 gig links. And finally, the single slot 100 gig dual NIC for placing the image frames in system memory or to GPUs. The equivalent CXP solution has the cameras, of course, but utilizes 3 times CXP12 quad frame grabbers to accomplish the same task. And here is what a 2 times 100 gig camera system would look like with Ethernet versus CXP12. The Ethernet cameras plug directly into the 100 gig dual NIC for a single slot solution. The CXP12 cameras need many multiple CXP cables to plug into the required 4 times CXP12 quad frame grabbers to accomplish the same task. We will note again that this is in theory, as no cameras like this exist to date. The common theme here is that CXP adoption for higher speeds is very slow. This slide is an illustration of how the proposed or ratified changes are converging the interface standards. USB remains mostly the same, but is a point-to-point technology. CXP has adopted the Ethernet physical layer, converging towards GigE Vision. GigE Vision plus RDMA and GigE Vision plus TCP, if and when ratified, is converging to CXP and USB as a point-to-point technology. This is perhaps 2 years out. GigE Vision plus GVSP will maintain its integrity and feature set and will not converge with the other protocols. So let's say we now have our data safe in system memory, by whatever means. Now what to do with it? For some applications, the CPU and system memory are a sufficient resource. For other performance applications using multiple 100 GigE, 25 GigE, or even 10 GigE cameras, real-time processing requires offloading the task to more well-suited processing nodes. CPUs and their system memory often cannot cope. Technologies designed to help here are GPU cards, where all the processing is done on the card, FPGA cards, processing also done on the card. GPUDirect is a method, of course, to get the data very efficiently without touching CPU, system memory, or the CPU itself, to GPU cards or FPGA cards. Peer-to-peer transfers are also there to move data from one processing node, like a GPU or FPGA, to another node. AI engines are features of GPUs and FPGA cards. The NIC market is converging with high-performance computing, so at some point here we'll see cards that have both the interface and the processing on the same card. They're already existing in a number of applications already. And then finally we've got storage and switch solutions. The switches enable us to multicast data from one camera to multiple servers, multiple processing nodes. GPUDirect is a fantastic technology and in use by many of our customers in AOI, drone, VR, and sports applications, to name a few. In this case, the CPU and system memory remain untouched, while the data is transferred directly to the GPU from the NIC. In one deployed real-time application, 24 times Emergent 25 gig cameras are transferring images direct to GPU, where H.264 compression is being performed, before passing the compressed images to the final destination. This is an implementation involving 2 100 gig dual NICs, 2 GPUs, and only a single server. In this case, the CPU and system memory are barely touched, and there is absolutely zero data loss. Emergent has supported these technologies for over 2 years now. One of the nice things about Ethernet is the vast cross-industry resource pool we can draw from. Xilinx is one such vendor we work closely with to provide advanced processing resources. To integrate with Emergent cameras, a customer could take their current GigE Vision core and port this to one of many cards like Xilinx Alveo, which already has the same interface as our cameras. For those new to GigE Vision drivers, we can provide ported firmware and drivers for the cards like these to get you up and running quickly and let you focus on the particulars of your application. With a quick search, you will become aware of the abundance of FPGA code resources at your disposal. These technologies are also not limited to a single video stream, but can handle multiple streams, limited only by the device resources. Emergent begins its foray into the PCIe card space, which provides certain benefits to our customers, like intelligent image reordering, routing, and expanded buffers. In addition, we have customers that wish to avoid switches in their setups, with cameras spaced far apart and at distances suitable for fiber. Yet they still want tight synchronization. Our front port trigger with action command for image triggering satisfies this need. Developing our own cards also allows us to manage the full supply chain for our typical customer applications, as well as maintain strict quality control. Emergent will also look to develop advanced processing cards to fulfill the needs of our customers, as well as application-specific modules to reduce time to market. These technologies are also not limited to a single video stream, but can handle multiple streams, limited only by the device resources. We have presented this setup during a few online presentations, as well as at trade shows like NEB Vegas and also at Vision Show in Stuttgart this past year. The system is by far the highest performance and highest density solution in the market. The system has zero data loss, taking in 210 gigabits of image data and storing it to 8 times U.2 NVMe drives. The server is a single mid-range AMD and ASUS server configuration that runs our eCapture Pro performance software. Some customers wish to take this setup and add GPUs in the available slots to perform real-time processing such as compression. We have customers who have scaled systems up to 250 plus cameras in a single system using our 25 GigE cameras. This exemplifies the ease of scalability. As mentioned, we have customers that wish to avoid switches in their setups. Switches can be more costly, starting at about $7,000 for a 48-port 25 gig plus 8-port 100 gig configuration through our partner network, but help to reduce the overall system cost substantially. Smaller configurations like 18-port 25 gig plus 4-port 100 gig are available as well. The switch market is also getting much more competitive as more companies come to market with 25 gig and 100 gig with PTP support. You can count on Emergent for support in switch supply and configuration. eCapture Pro is built on top of Emergent's ESDK and is the glue that allows us to achieve the highest performance in the market. Processing node technologies are being added and supported for custom performance deployable systems. While generally not appropriate for the highest performance applications, Emergent cameras can be operated with third-party software such as Cognex, MVTEX Halcon, and National Instruments LabVIEW. Some of these companies are actually integrating GPU support to actually offload a lot of that strenuous processing to other processing nodes. Lastly, I'd like to talk about the cameras, starting with area scan. Emergent area scan cameras are very full-featured. We have resolutions from 0.5 megapixel up to 150 megapixel. We have the highest possible frame rates. As some examples of those highest frame rates, we have a 2 megapixel camera operating at 3,462 frames per second, a 10 megapixel camera operating at 1,000 frames per second. Those two are examples of what we can achieve with the Zenith 100 gig product line. And of course we have multispectral support with color, monochrome, UV, polarized sensors, NIR, and SWIR. Moving now to line scan cameras. Emergent line scan cameras are incredibly full featured. We have resolutions from 4K up to 16K, we have the highest possible line rates. Some examples of those are 4K at 172 kHz and 16K at a whopping 400 kHz. We have encoder support, and the types of sensors that we support here are TDI, monochrome, and color. I wanted to provide a couple of examples where customers have come to us reporting poor experience with another vendor's high-speed camera product. In one such recent example, we have five GigE cameras on a single PC. Over a 2-year period, the vendor made many attempts to resolve drop frame issues, but never could. In another example, the customer is trying to run 8 10 GigE cameras on a single PC. The vendor's comments were that they'd never tested more than 2 cameras per PC. Both of these customers are now happily using Emergent product. There are 2 very disturbing problems here. One is the poor performance some vendors are offering for their high-speed camera product. The other is that a vendor would actually sell multiples of 8 cameras without having a discussion about what the customer's goals are to ensure the product can meet their needs. The critical lesson here: make no assumptions about any company's ability to provide a quality high-speed implementation for any camera count. Experience, dedication, and a solid track record in high speed matters. Our cameras are everywhere you care to look. We dominate in certain spaces where adoption rate is more rapid. We believe other spaces will follow, especially where factors such as performance, cost sensitivity, system simplicity, and time to market are at play. As you can see, Emergent has the highest performance product portfolio, and we keep our overall product portfolio focused. We innovate, develop, adapt, and expand the markets we enter, and have the foresight to do so. Please do contact us for further details, and we appreciate you taking the time to view our presentation.